Hi, welcome to my video on proofs in coordinate geometry, part A. Proofs or show or justify or verify. All of these words are used to show that a statement is true. And if you wish, you can pause your video and work each of these out before I do. And here we go. Show that 2x plus y equals 7 passes through the midpoint of AB if A is negative 2, 3 and B is 4, 7. Well, if this line passes through the midpoint, that means that the midpoint subbed into the equation will make the equation true, which means that that line passes through it or that midpoint lies on it. So let's find the midpoint of AB. And the midpoint of AB is the average of the x's. So it's x1 plus x2, which is negative 2 plus 4 over 2. y1, which is 3, plus y2 is 7 over 2. So that's 2 over 2, which is 1. 10 over 2, which is 5. So that's the midpoint of AB. So if that point subbed into the equation, when x is 1, y is 5, so if you put 1 in and you put 5 in, oh, I got too high there. Let's just ignore that. 2 plus 5 equals 7. 7 equals 7. That's true. So that line passes through the midpoint because the midpoint, which is 1, 5, makes the equation true. Number 2, prove that the triangle ABC is isosceles if P is 3, 4, and Q is 1, negative 2, and R is 5, negative 2. What I do is that I draw a quick sketch of what I have. P is 3, 4, so let's just mark 3, comma 4. I'm only doing a rough picture of what I see. Q is 1, negative 2. There's Q. And P is 5, negative 2. So there's R. So the triangle is this triangle right here. And I should take the Q out of there and put it right here. So it says show that the triangle is isosceles. An isosceles triangle has two sides equal. By drawing a sketch, you can see roughly that PQ is going to equal PR. So that means we have to get the length of PQ using the distance formula. And we have to get the length of PR using the distance formula. And when we work both of them out, then it's isosceles. So let's go with PQ. So P is 3, 4, and Q is 1, negative 2. So that's x1, y1, x2, y2, and the length, so it's x2 minus x1 squared, y2 minus y1 being squared, and we sub them in, so it's negative x2 is 1, x1 is 3 squared, y2 is negative 2, subtract y1, which is 4, and we work out the brackets first, so it's a negative 2 squared, negative 6 squared. That gives negative 2 squared is 4, negative 6 squared is 36. That works out to be the square root of 40, and the square root of 40 is the square root of 4 times 10, which is 2 root 10, if you want to simplify it as a radical. And RP, or PR, we have we have the point 3, 4, and we have the point 5, negative 2. So this is x1, y1, x2, y2, and we got x2 minus x1, y2 minus y1. Notice I write it down, so I keep writing it down all the time, so it's easy to remember. So x2 is a 5 minus x1 is 3. Y2 is negative 2 minus y1, which is 4. And we simplify the brackets first. That's a 2 squared. And that's a negative 6 squared. So 2 squared is 4. Negative 6 squared is negative 6 times negative 6 is 36. That's the square root of 40. And again, it's the square root of 4 times 10. So it's 2 root 10. So I could have left them as square root of 40 and square root of 40. And notice that PQ is equal to RP, which is equal to 2 root 10. So the triangle is isosceles because two sides are equal, or because of the definition of an isosceles triangle, ISOS for isosceles. So the triangle is isosceles because two sides are equal. Okay, let's do another proof. Number 3. It says that, see all the coordinates, there's point E, point F, point V, point T. Is EF perpendicular to VT? Justify. So EF is perpendicular, so perpendicular means that you have negative reciprocal slopes. So I'm going to get the slope of EF and work it out. So E is, let's write down E, is right here. So let's put E as 6, negative 2. And let's put F as 0, 1. So the slope of EF is y2 minus y1 over x2 minus x1. And so y2, if we go with this one as x1, y1, x2, y2. So it's a 1 minus a negative 2. x2 is 0 and x1 is 6. The double negative is a positive, so it says 3 over negative 6, which is negative 1/2. And we're looking at VT. So V is negative 1, negative 3, and T is 3, 5. So if we call this one x1, y1, x2, y2, so the slope of VT slope is y2 minus y1 over x2 minus x1. So y2 is a 5 minus a negative 3, which is y1. x2 is 3 minus a negative 1, which is x1. We got a double negative and a double negative, so that's 8 over 4. And 8 over 4 becomes 2. And the slopes, so notice, the slopes are the negative reciprocals of each other. Hence, the segments are perpendicular because of negative reciprocal slopes. Notice when I finish proving it, I finish it off by writing a statement. And I didn't write a statement for this, but I made it that since the point satisfies the equation, therefore it passes through it. Okay, let's do some more. Show the quadrilateral ABCD is a parallelogram. Again, if you draw a quick picture of what you have, A is -2, -1, and B is x is -1, y is 2. So that's A, and that's B. C is 4, 3. So let's say that's 4, 3. And D is 3, 0. So if we join them up, A to B to C to D, you can see that we have this makings of a parallelogram. Now there's a couple of ways to prove parallelograms, or many ways. One of the fastest ways to do it is to draw your diagonals. If you draw your diagonals and you show that the two diagonals have the same midpoint, they bisect each other. And since they bisect each other, we have a parallelogram. So let's do it that way. That's the fastest way. So let's get the midpoint of the diagonal AC. At AC, the midpoint of AC, A and C, 4, -2, is, add them up, you get 2 divided by 2 is 1, and -1 and 3 add up is 2. 2 divided by 2 is 1. And the midpoint of the other diagonal BD, there's B and there's D, add them up, -1. AC, that's -1 plus 3 is 2. 2 divided by 2 is 1. 2 plus 0 is 0. 2 plus 0 is 2, divided by 1 is 1. So notice the midpoint of AC equals the midpoint of BD, and since the diagonals have the same midpoint, they bisect each other. Hence, A, B, C, D is a parallelogram. Oh, pen ran out. Is a parallelogram. That means ABC is a parallelogram because the diagonals bisect each other. So the proof is done. And another way to do that would be to look at the slope of, let's look at A. We could do it by looking at the slopes. So the slope of AB is y2 minus y1 over x2 minus x1, and that's double negative, so that's a 3, and double negative, so that's a 1, so the slope of AB is 3. Now we look at AB is parallel to CD, so let's copy down C and D. So C is 4, 3, and D is 3, 0. And again, we'll get the slope of CD, y2, 0 minus 3 over x2 minus x1. That's 3 minus 4. And we have negative 3, make that a negative 3 over negative 1, which is 3. So notice that AB is parallel to CD because the slopes are equal. Now let's do the slope of BC. The slope of BC, B and C. BC is here. So we have, let's copy down B. And we copy down C as 4, 3. So the slope of BC is 3 minus 2 over 4, subtract negative 1, double negative. So that becomes 1 over 5. And we'll get the slope of, we got BC. So BC is parallel to AD. So let's do A and D. A is negative 2, negative 1. And D is 3, 0. So the slope of AD is 0. Subtract negative 1 over 3, subtract negative 2. Double negative is a positive, so it's 1 over 5. So that means that BC is parallel to AD because the slopes are equal. And notice that A, B, C, D is a parallelogram by definition of a parallelogram, which is opposite sides are parallel. So notice the fastest way to do it is do the two midpoints and say since the diagonals have the same midpoints, they bisect each other, and because they bisect, we have a parallelogram, or even do all the slopes. That would be your choice. Now, number 5, A, B, C, D are the points. Show that AP is the altitude of the triangle ABC. Again, draw a diagram. A is 0, 2. A is 0, 0, negative 2. So there's A. B is negative 4, 3. Right there. C is 4, 1, which is right there. And P is 1, 2. So let's join the diagram up to form the triangle. So we have A is 0, negative 2, so that's A, and that's B, and that's C, and there's P. Now what happens when you do a rough estimate? We don't know if P lies on BC. We could prove it if we want to do linear, if points are collinear, then they would be on the line. But we want to prove that AP is an altitude of triangle ABC. So let's join these up. Let's join this up. So AP is an altitude if they're perpendicular. So when you leave a vertex and go perpendicular to the opposite side, that makes AP an altitude. An altitude are perpendicular, and perpendicular lines have negative reciprocal slopes. So let's get the slope of BC, and B is negative 4, 3, and C is 4, 1. So the slope is y2 minus y1 over x2 minus x1. And so that's a negative 2, double negative is positive, over 8. So that's a negative 1/4. Now, if we get the slope of AP, so A is 0, negative 2, and P is 1, 2. So the slope is y2 minus y1 over x2 minus x1. Double negative is positive, so that's 4 over 1, which is 4. And notice, since the slope of BC and the slope of AP are the negative reciprocals of each other, that means that AP is perpendicular to BC, which means that AP is an altitude of the triangle ABC, because an altitude leaves the vertex, it goes perpendicular to the opposite side. Okay, a couple more to do. This is the first video on proving using the ideas of midpoint, distance and slope and equations to do different proofs using coordinate geometry. So this is the first one now, and I didn't want to do them all on one. I wanted to do them in different videos because of the length. Number 6, T, which is 4, 7, lies on the circle with center 2, 3. Where does the point W, which is negative 3, negative 4, lie? Inside, on, or outside of the circle? Justify. Well, again, just to draw a picture, the center of the circle is 2, 3. So there's the center, which is O. And 4, T is 4, 7. So 1, 2, 3, 4. That's 3. Let's pretend that it's up there. So there's T. So if that's the center and this point lies on it, that means that I have approximately, this is just me drawing, if that's the center and that point lies on it, that means that OT is a radius. So OT is a radius. And all points that lie on the circle are equal distance from the center. So if I take this point right here that lies inside, then it's going to be, if whatever the length of the radius is, then this distance is going to be shorter than the radius. If the point is right here on the circle, then OT would be the same as this distance because all radii are equal. A circle is points equal distance from a fixed point. And if the point lies out here, then that means that this distance would be greater than the radius. So let's go and find, let's take the point. So OT is the radius, so let's take the point OT and get the distance of OT. So T is 4, 7, and O is 2, 3. So we'll get the distance, and the distance is defined as the square root, and distance formula is a little bit more awkward, so we'll write down x2 minus x1 squared, y2 minus y1 squared, and we got the 2 points here, so it's x2 is 2 minus 4, x2 minus x1 plus y2 minus y1, and so that's negative 2 being squared, and that's a negative 4 being squared. We always work out the inside of the bracket first by PEMDAS. Negative 2 times negative 2 is 4. Negative 4 times negative 4 is 16. That's the square root of 20. And the square root of 20, that's the square root of 4 times 5. So it's a 2 root 5. And now we take the other point, which is W, and W is a negative 3 and a negative 4. So negative 3 and a negative 4, negative 3, negative 4 is here. So as you can see from the diagram, that W is lying outside. But we have to prove it. We have to justify. So just drawing it won't do it. We could, but again, we'll get the length of OW. So again, O is 2, 3, and W is negative 3, negative 4. So this is x1, y1, x2, y2, and the distance formula is x2 minus x1 squared, y2 minus y1 squared, and x2 is negative 3 minus x1 is 2, add on, y2 is negative 4, subtract 3 squared. So that gives us negative 5 being squared, negative 7 being squared. You always work out the brackets first. 5 squared is 25. Negative 7 squared is 49. And add that up, you get a 74. 74 is 2 times 32 into 74 is 14. So 2 into that is 2, 6, 1, 4 is a 7, 37. So it can't break down because this is an odd number. But the square root of 74 is greater than 2 root 5, or we could call it root 20. And because it's greater, that means that the point lies. So that means that root 74 is greater than the radius, which is root 20 or 2 root 5. So it lies outside because the distance is greater. That's the then there, right there, just to make sure. Okay. Number 7. We have these coordinates of the J, F, H, and I. Prove the diagonals of a quadrilateral bisect each other. And we just did that on the previous proof. The diagonals bisect each other if they have the same midpoint. So let's draw the figure first so we can find out where the diagonals are, just to make sure. F is negative 1, 5. 1, 2. So let's put it right there. So there's F. H is 3, 5, which is right there. And I is 6, negative 1. So that's an F, an H, and an I. and j is 2, negative 1. So let's join. This is F, H, I, J. F going to H, going to I, going to J, and back again. Now you can see that you have the diagonals. There they are. So the diagonals are Fi and Hj. A diagonal goes from one vertex to another, not being a side. In other words, it can't go through consecutive vertices. It's got to be non-consecutive vertices. So if we get the midpoint of Fi, and let's put down F, keep them close together, and Fi, I is 6, negative 1. And I'll write this down this time. The midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. So what I'm just doing, I'm just getting the average of the x's. So it's a negative 1 plus 6 over 2, and 5 plus negative 1 over 2. So that's 5 over 2, and that's 4 over 2. So that simplifies to 5 over 2, or 2.5, and 2. Now I'm going to get the midpoint of the other diagonal, which is Hj, and H is 3, 5, and J is 2, negative 1. And again, I have it written down here. I add up the x's, divide by 2. I add up the y's, and divide by 2. Okay, and that gives me 5 over 2, 4 over 2. So that's 5 over 2 and 2. Sometimes when you just got to be careful, you write everything down correctly. And notice that the midpoint of Fi equals the midpoint of Hi. And since the midpoints are equal, the diagonals bisect each other. So the diagonals bisect if they have the same midpoints. So that's one review, or should I say not a review, but reviewing the properties, or reviewing midpoints, distance and slopes, and equations of lines, etc. So that's proving properties related to triangles, parallelograms, using the coordinates of the points. And that's one done of some proofs. There are 2 more videos coming on proving properties. And if you like my video, click the like button, click the subscribe button, visit my website www.mathfullyexplained.com to find more information about me, my videos, and the content of my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.